economic dispatch problem. And these are the result. Result means when we are getting this value now, G1, G2, G3, G4, we have to plot this, all the value in T1 to T24. I am plotting this value in MATLAB. Means whatever we are getting the value of T1 to T24, we are just put the value and plot this curve. And these are the demand data. Yes, we are forecasted data we have already said about whatever we are taking the demand data. And these are the generated power output. So these are the simple problem of economic dispatch. It is all clear or not? Any problem? So that कोई किसी को problem? Yes, I am audible, all of you. Hello.
Yes, yeah, sir, you are audible.
Okay. Now, when we are integrating the wind, when we integrate the wind, integrating economic dispatch, you can also add the wind power. Means we are adding just our objective function, economic dispatch plus wind curtailment we are adding. So similarly way we have to write this equation, and we have to write the wind power, wind curtailment power. Okay. So by using this wind integrated problem, just same example, same are there, same data are there. Okay. We have to add only the wind data. I am already adding the wind data, and by using this, we have to, these are the same problem we are written. We have to add only the sum of T VWC into PWC TT. Okay. So wind curtailment into wind power. So we are already given, VWC is a scalar, that is 50, already given. Data is already given. So by using this, we have to solve this QCP. And last one is display. Display is we have to display all those things, means cost, or we can say power, or we can say power curtailment. Whatever the variables you can define, you can display also in GAMS. Okay. So these are the output when we are defining the wind. When we are adding the forecasted wind data, then the cost will be this. We can see there the objective function will be reduces as compared to without wind. If you go for without wind, now when we are not considering the wind, then the objective function will be higher as compared to wind when we are considering the wind. Obviously, if you add the wind, the objective function will be reduces. So objective function will be reduced, and cost and all the generator function, all the 24 hours also reduces. So these are the cost and also the power generator of thermal of cost based economic dispatch. And these are the graph of power generator, that is G1, G2, G3, and G4. All the generator when we are getting those value, these are the generator value. We are putting this value and we plot this curve. And these are the thermal bar value and load and power curtailment. So we got the result of this power and as well as thermal value. Okay. So these are the result of wind economic dispatch problem. Okay. Now, before going economic dispatch, now we have going for unit commitment. And what are the basically difference between economic dispatch and UC? That is the most important question. Economic dispatch we have to minimize the cost, but in unit commitment we have to minimize the cost, and also we have to minimize the startup and shutdown cost. We have to minimize the startup and shutdown cost. So that's why we are going for unit commitment. Unit commitment we have to solve problem by mixed integer programming, because unit commitment is nothing but once when the generator is on and generator is off, depends on whatever we are taking the data. So unit commitment is basically which generator is on and which generator is off. It depends on the student data. So that's why we are taking the unit commitment problem. Unit commitment problem, basically, when we are solving this problem, according to GAMS, we have to go for MIP, because mixed integer programming, because these are the discrete or continuous variable. That's why we are writing the MIP, mixed integer programming. If you go for economic dispatch, you go for QP, that is quadratic programming, or we can say non-linear programming. So that's why we are taking the MIP. So the unit commitment problem is the most important, or when we are going for non-linear programming, that is MINLP. So these are the addition, MIP plus NLP, that is the MINLP, that is mixed integer non-linear programming. If you are having non-linear data also, if you are having integer value also, then we go for the large scale problem. If you have large scale complex problem, non-complex mixed integer non-linear programming, then we talk about the mixed integer non-linear programming, that is MIP plus NLP. Then we can write the MINLP. So these are the unit commitment problem and ED dispatch problem. This is the main difference between about the unit commitment and economic dispatch. So what is basically unit commitment? As I already say about the unit commitment is basically the unit which unit is on or off. It depends on shutdown or startup cost. So the unit commitment we can solve the problem in week also, month also, or year also. So these are the objective function. In earlier slide, we already studied the economic dispatch. That is the fuel cost. So we have to minimize the cost, fuel cost also. We have to minimize the startup cost also, and we have to minimize the shutdown cost also. So these are the objective function of economic unit commitment. And these are the constants. Similarly, constants are there. And these are the constant of P minimum, P maximum. We already said about, so we do not repeat again. So what are the challenges regarding of unit commitment? Basically, they are having two parts: the conventional unit commitment and deregulated power system. So unit commitment divided in two parts, that is SCUC and PBUG. SCUC means security concern unit commitment, and PBUG is price based unit commitment. SCUC basically depend on system operator, where the system operator deals the deregulated power system. Means SCUC perform the deregulated power system and is to minimize the operating cost or maximize the security with having some prevailing constraint. So SCUC always perform the system operator. But if you go for PBUG, PBUG is a price base. We are saying the price base means it depends on electricity marketing, where the GENCO bids the price or send the price. They are depends on PBUG, that is price based unit commitment. So most of the researcher they are doing in today life, that is PBUG and SCUC. SCUC, I have done my research work in SCUC. My objective is we have to minimize the cost in deregulated power system criteria. That is my objective. So I have done the in research work SCUC, that is stochastic security concern unit commitment. Stochastic means this is a multiple problem, and deterministic means that is single problem. I will go for in the next slide. So SCUC we have to minimize the cost, and PBUG we have to maximize the profit. So these are the classical area when we are going for unit commitment. You can see most of the research work in 1990, 89 to 2020. Still, most of the paper means you can say 10,000, 20 lakhs paper are there in unit commitment. Okay, when the deregulated power system is come, then the number of problem in SCUC, because deregulated power system is basically the process of removing or reducing the state regulation, means is the re-regulation. When the system will be going re-regulation, the system in already market, then they are having some competition. So they are the deregulated power system. So deregulation nothing but is the process of removing or reducing state of regulation, typically in the economic criteria. It is the repeal of government regulation of the economy. So we can say the deregulation. Most of the in the earlier 2001, since 2001, most of the system are regulated framework. But today in monopolies came from all the deregulated criteria. All generation company, transmission company, system having own monopoly. So they are deregulated. So that's why we are going for SCUC problem in deregulated power system. And we have to minimize those costs in SCUC problem. So these are the basically criteria of SCUC. Now SCUC having two parts, most of the problem we can see in research paper article, SCUC having dividing master problem, sub problem. We do not go for this way because these are the vast area. So that's why we are not going. These are the three parts, GENCO, TRANSCO and DISCO. These are the calculation of how to calculate the SCUC problem. Now, what are the main objective function of UC? We are already said that the economic dispatch problem. Now we going for the economic unit commitment problem. So unit commitment problem, they have to minimize the number of generator, that is 1 to number of generator, and T is the time, and they are the objective function, that is fuel cost into UIT. UIT the commitment structure. UIT we are defining here. Here we are defining UIT. UIT means the commitment structure. Which generator is on and which generator is off. It depends on binary variable. It may be continuous discrete variable. So we are writing the UIT. ST is the startup cost and ST is the shutdown cost. By using this constant, we have to satisfy all the constraints. Generator capacity, as we say on dispatch also, but here we can write only UIT. We are adding the UIT. UIT and system power balance is PI UIT, and forecasted wind is equal to demand. And they are having system spinning reserve requirement. Means we have also taken the reserve requirement. We all means if you had large number of constraint, means GAMS is the solver is if you had number of constraint, means it may be spinning reserve constraint, it may be the regulation constraint, it may be the reserve constraint, whatever we were adding, marketing constraint we also adding. So if you add large number of constraint, whatever depending on the problem, It depends on problem, whatever we are taking the objective function. So we are taking this just a simple example. These are the objective function, and these objective function, they are having some constraint are there. So by using this problem, we have some data. Sorry. Also, we are taking. They are having also constraint are there. Minimum up and down constraint are there. Ramp rate limit are there, and there are some other constraint are reserve constraint, emission limit. Already say about transmission line also constraint. Transmission line means it may be the DCOPF, it may be the ACOPF, or we can say these are the transmission line constraint. Okay, reactive power constraint, voltage transformer transfer limit, whatever be the constraint we are taking. So the GAMS solver we can easily solve. Okay. So we are taking the simple example, that is 6-bus system. These are the most important example, easiest ways example which can be used in our system. Okay, so we are just taking the system 6-bus system. Okay, and these are the table of generator data. These are the coefficient data, and these are the load data, load and forecasted wind power data. So these are the data we are taking. By using this question, we are just put our value in a similar way, but we are adding the some minimum up and down. Means we have had some constant are there. In earlier economic dispatch problem, we do not have minimum up and down constant. So we are adding minimum up and down constant. We can define the sets of minimum up and down constant. Okay. And generator data, similar way, we can write the generator data. Demand, we can also write. And these are the variable, fixed, that is total cost, power, UIT we are adding. UIT is the commitment structure, which generator is on and which generator is off. So we are just writing this UIT. Then we are writing YIT, that is startup cost and shutdown cost. So in the earlier slide, we are defining the economic dispatch. But when we are going for unit commitment now, we have to define the unit commitment, that is on-off startup and shutdown. So we are written minimum up and down time also. So these are the binary variable U, Y, and Z. Obviously, because these are 0 and 1 binary variable, so we can write binary variable U, Y, comma Z. These are the extra addition we are taking in unit commitment problem, U, Y, Z. And these are the equation we are defining. So these are the equation. In the earlier slide also, we are already written how to write the ABC coefficient, and how these are the addition of shutdown and startup cost. Similar way, and we have to write the shutdown and startup cost equation, equality constant and inequality constant, startup minimum up and down constant, maximum and minimum in similar way. We have to write similar way in other side also. Okay, so we have to model the unit commitment. Okay, we have to model that, and we have to minimize the MINLP. Why I'm using MINLP? Because these are the mixed integer nonlinear programming. Mixed integer because we are using the unit commitment, that is the binary variable. That's why we are using the MIP or NLP. NLP, why? Because they are non-linear. That's why we are using MINLP. MIP plus NLP, that is MINLP. So we have to minimize FT, that is objective function, using MINLP. And we have to display the P output and unit commitment stresses. So let us see the result, how we are getting. These are the unit commitment result. Means all 1, 3 are all the unit are committed. Means these are the cheapest unit, and 6 to 7, 90, 24 hour. In second unit, the unit will be committed. These are the costly unit because they are committed only 7 to 24 hours. Sorry, 6 to 24 hours. So this operating cost will be in this. If you go for forecasted wind, if you add wind power, then the cost will be reduces and commitment will be also reduces. Obviously, if you add wind power without wind, the cost will be this. If you add wind power, then cost will be this. The cost will be reduces and commitment also reduces. So that's why we are using add the mode wind power. If you add energy storage also, then cost will be again reduced with the case number 2. So these are the dispatch, because if you go for the unit commitment, it's a binary variable. Then we also go, means power also we have to also get the power, that is power output of generator I, means 1, 2, and 3 generator are there. So these are the dispatch of without wind units or with forecasted wind power. So these are the equations which can be used in the most probable scenario. Okay, so now we are already study about what are the economic dispatch and what are the basically which can be used in the power system that area. Okay, so these are all about things which can be used in the day-to-day life, and most of the researchers are doing right now also economic dispatch problem. So okay, so I will conclude in this. Okay, shall I conclude? Hello.